All right, let's kick off. First off, thanks very much for phone call for hosting us tonight. Without generosity, like having somewhere to come to be, also stick around and have some pizza and drink. So tonight's format, Graeme's going to present for just under an hour. Sometimes some questions. We're going to break out for just quick bites a week. We're going to come back in for a very much shorter session after that. So please stick around. There's going to be some more open format sort of discussion after the break. I can tell you that's actually quite in the past area for discussion. My name's Angus, that's Matt. We organised the DevOps meetup. Also, after the break, we're just going to be doing a bit of a retrospective on what we've learned out of the DevOps conference here in Brisbane recently. It was a great event. If you didn't get to attend, we'll talk about some of the stuff catch up online. Because there'll be other people in Brisbane who did go, who will be leaving you in dust. Without me cutting on for any longer, this is Graeme. I appreciate you coming from Red Hat tonight to have a bit of discussion with us. And feel free to reach out to either Matt or I during the break if you've got good presentation ideas. Okay?
Good evening, everyone. My name's Graeme Gillies. I'm a cloud architect at Red Hat. Today I'm going to talk to you about Docker and Openstack. I do apologise for the slightly cheeky title there, next-gen infrastructure. It's a bit buzzwordy, I know. So yeah, let's get started. So just quickly go over the agenda of what I'm going to cover today. Quick slide on who I am. An overview of infrastructure itself. I know that seems kind of silly considering we all deal with infrastructure all the time. I think it's worth just covering a few quick points about infrastructure and the terms we're going to use, I will be using and what I'm going to be talking about, just to make things a bit clearer throughout the talk. We'll have a look at Openstack itself, what it provides, what it brings to the table. We'll also have a look at Docker and container management, which I'm sure everyone's very interested in at the moment. We'll have a little bit of a demonstration. I've got 2 demos today of Docker on top of OpenStack, and in true style, expect those demonstrations to probably fail horribly. Hopefully they don't, fingers crossed, so we'll see how we go. And then we're just going to cap that off by talking about what I think the future holds and what that kind of means. So who am I? As mentioned, I'm a cloud architect at Red Hat. I come from a systems administrator / operations background. I was a Java developer a long time ago, but I'm very much a operations staff these days. I have over 3.5 years experience building and maintaining private clouds at Red Hat. So infrastructure overview. So once again, we should all be fairly familiar with this. I won't dwell on it for too long, but once again, it's probably worthwhile pointing out, especially as we talk about things like Openstack further down. This is the typical layers you would see in an infrastructure. Obviously, at the bottom you've got hardware. Now more and more you're seeing hypervisor directly on top of that. An operating system, application platform, and then obviously the application yourself you're writing and deploying. So here what I've got is just what I would put as a very, very simplistic application ecosystem, and a couple of the terms I've kind of used there to describe some of the bits and pieces. So in a fairly typical, fairly simplistic kind of application ecosystem, you'd have what I would call the group of front door technologies. So things like load balancers, firewalls, content accelerators, those kind of bits and pieces. Now they can be hardware devices, they could be software devices, but they're typically things you kind of put at the front to the first kind of thing that people using your application kind of hit when they hit your infrastructure. Directly beneath that, we have obviously the kind of application group, which is something obviously we're all very, very interested in. So that's things like your business logic, your application servers, all your code, and all the kind of deployable bits that you typically would put in there. And then typically behind that you have some kind of data store. So whether that's an SQL or an NoSQL database, a key value store like Redis, or it could be just something that, like a shared NFS file system that you're dumping a whole bunch of images or binary data. Obviously that's something we're seeing less of these days, in particular with services like object storage and so forth, but they all kind of fall in that same category. And typically you don't just have those things. obviously we have what I call an operations management kind of group. Doesn't necessarily have to be operations management, but it's things like your monitoring, your alerting system, your centralized logging system, your system management tools, anything that's not directly related to your application, but you kind of need it to provide good service for that application. So Openstack. So how many people here have heard of Openstack? Yeah. How many people here are using Openstack? A couple of people, that's good. Fair enough. So obviously if everyone's familiar with Openstack, I once again won't go into too much detail about Openstack itself. But one of the things I do notice is that when people talk about Openstack, there's a couple of pieces they all talk about a lot and understand quite a lot. And then there's a lot of other pieces that are kind of just peripheral, that are waiting in the wings, and there's either in development or just up and coming, that people might not be so much aware about. So the services Openstack provides you, straight off the bat, are what we call compute, networking, and storage. They're kind of the big, obvious ones. You get compute service, you can run up a virtual instance very, very quickly and easily. They give you some networking around that. Obviously, your virtual machine or instance needs to connect to one or more networks, so it plugs all that in for you. And then typically you want some kind of storage behind that as well. And so Openstack can give you storage as a service to attach and detach to various different virtualized parts of the infrastructure. So now I'm just going to go through a couple of the other projects that Openstack either has already incubated into the core or up and coming in development. So there's load balancer as a service, which is a new feature of Neutron, which is the Openstack networking component. So that's very interesting in that it provides a set of APIs, a unified interface, and a pluggable architecture to actually hook into hardware and software-based load balancers. So rather than having actually go onto an F5 load balancer and configure it yourself, you can simply configure Openstack to talk to that load balancer, and then just through the Openstack web UI, define all the bits and pieces you need for that load balancer to do. So there's database as a service, and this is just landed into the main core group of Openstack projects in the latest release. That's called the Trove project. As you can see, Openstack, all open source projects seem to be obsessed with giving themselves cool, funky names that make absolutely no sense. Right? So some of the names are a bit hard to follow. But yeah, so Trove project is the database as a service functionality. So what that aims to do is once again provide you a set of APIs, a set of plugins, and a clean, easy way for you to be able to provision databases and other data stores quickly and easily through the same kind of API ecosystem Openstack gives you, rather than you having to, example, build a whole instance yourself and then install packages onto it, set it all up, and set usernames and passwords and everything else. So there's monitoring as a service, which has been in core Openstack for a while now, and it's just starting to reach maturity. So that's part of the telemetry project. So what that was kind of an interesting one, because when you kind of think about it conceptually, it's a little bit harder to understand what really is monitoring as a service. What that actually means is a couple of things out of the box. Out of the box, it'll give you all the basic kind of components you'd expect from system monitoring. CPU, disk usage, network usage, those kind of bits and pieces. Once again, it gives you plugins, it gives you APIs, and it gives you a solid way to integrate that with monitoring any kind of piece of software or even hardware that you would desire. And that feeds that back once again to the Openstack ecosystem, and we can leverage other parts of Openstack as we can we'll see in a little bit. Now, of course, we have one of the latest projects that's up and coming, which is Manila, which gives you file system as a service. Probably not the most exciting thing these days, especially with Openstack having the Swift project to do object storage, and that seems to tend to be the better way for people to store data. But at the end of the day, there's still sometimes the need to have a file system, typically a clustered file system or a network file system, accessible to one or more pieces of your infrastructure to put bits of data on. How that's actually implemented, once again, set of APIs, set of plugins, so it could work with your NetApp storage array, or it could work by building you a cluster or FS cluster straight from nothing. So very flexible. And lastly, VPN as a service, which is also a neutron, the networking component. And I think it's a bit funny why I'm kind of mentioning that in all this. We typically associate VPNs with like just people connecting to work from home or things like that. What we're seeing more and more, the messaging on what the future kind of holds for us is we really do believe in the concept of hybrid cloud. That is, some people are going to go to Amazon and Rackspace and all those other public cloud providers. Some people probably won't, for various different reasons. They'll stick on private cloud, excuse me. But majority of people, it seems to be equating that they're going to kind of try and do both. They find a good balance between being able to burst onto public cloud from private cloud, maybe, or something like that. So once again, having an Openstack, being able to tear up and bring down VPNs within itself, within its own ecosystem, that other components can be aware of, so that you can orchestrate them all together, is quite important, especially if you're looking at maybe connecting infrastructure to a public cloud service. So we talked about all these individual bits and pieces. So we talked about all these individual bits and pieces. So, what is the advantage of kind of having OpenStack to all this stuff? And I guess it's worth mentioning that everything I talk about in OpenStack here, if you've used Amazon before, you're probably thinking, oh, well, there's an Amazon equivalent for that. And yes, essentially there is. You can take everything I talk about here with OpenStack, and if you're a company that's fully invested in the public cloud, Amazon probably has one. In fact, I'm sure Amazon has offerings to do pretty much everything the same. So what is the advantage about having all this OpenStack to all these things? A lot of them you can still manage yourself, or a lot of them you can just build those services yourself using your own configuration management tools inside virtual machines or on bare metal machines inside your environment. So there's one project that's been in OpenStack for a while now called Heat, which is basically system orchestration or infrastructure orchestration inside of OpenStack. It's the equivalent to Amazon Cloud Formations, if anyone's familiar with that. So basically it allows you to kind of give a template or define your infrastructure as code, which of course is something that a lot of people are very excited to be able to do. So I'm going to show you just a quick example of a Heat template. Hopefully this will work. So apologies that this is a bit hard to read. So basically, Heat, and once again, Amazon Cloud Formations, and there's a few other different standards out there about doing infrastructure orchestration, allows you to take all those services I talked about earlier and kind of bind them together with one kind of recipe or format to deploy all those bits and pieces and make them aware of each other. So you can see the standard template at the top here has got a whole bunch of, variables that it will prompt the user for, and in the demonstration later, you'll probably actually see those in action. Yep. It creates a whole bunch of resources, including virtual machines, and you can see in this simplistic example, they're simply just using some bash magic to actually do some work once the virtual machines are provisioned. There's nothing stopping you from using your standard configuration management tools, or indeed any way to actually configure the system that once they're running. Heat doesn't make any assumptions about that. It's only about the infrastructure pieces themselves. So we have what we call an auto-scaling group here, which is a group of auto-scaling servers. In this case, they are web servers. So once again, that folds back into the OpenStack telemetry service where it can monitor what's going on, and then scale up or scale down the group of servers based off the monitoring performance of that. So you can see here, we're actually looking at some scaling policies and some alarms. So we have an alarm here that says if the average CPU is over 50% for 1 minute, we need to scale up our web server. And likewise, there's an alarm a bit further down. So that says when the average CPU falls below 15%, we can scale that back down. You can see here we've got, at the bottom here, we've got a load balancer that obviously is what you need to actually sit in front of your scale up and scale down web group and so forth. So I won't go into any more detail on this because what Heat does and what it can do and how to actually use it would probably cover a whole hour by itself. But you can see here that in a simple recipe that's just a YAML file, you're able to start leveraging all those bits and pieces. Rather than you having to go and utilize them yourself, you can actually bind them together into a template that describes your entire infrastructure. And then you can version that and put it in Git, you can do whatever you want with it. So the other part we're going to try and talk about today is Docker. So you can see there that Openstack, when we go back to talking about both the layers of infrastructure and also the different groups that you might have in an application ecosystem, you can see that Openstack tries to provide various bits and pieces of that. It tries to provide a bit of front door, a bit of data storage, a little bit of the kind of operations management stuff. And it tries to give you all of those building blocks for you to utilize as you see fit. So the second part of this story, and the other thing I'm going to be talking about a little bit today and showing you, is Docker. So, hands up who's heard of Docker. Hands up who's using Docker. Yeah. Keep your hand up if you're using it in production. Yeah. So that's probably, I would have been very worried if lots of people put their hands up with Docker. So obviously Docker is one of the new technologies on the block that's creating a lot of waves, and it's very positive, it's very good. So the Docker is based around the idea of container management using a Git-like workflow. So how does it kind of, and this is a question I often get asked a lot, or people maybe not get confused, but kind of are interested in the possibilities of this. When you take things like Docker, you take things like Openstack, you take things like Amazon, you take things like platform as a service, which is something I won't be covering tonight, which is also another whole probably 1 hour plus session I can talk about. Which one is the best, or which one is the one I need to use? And it's not really that simple, because all of these technologies, especially in the cloud space, there's a lot of marketing going on and there's a lot of buzzwords going on, but they kind of, at the end of the day, have different functions. What often happens is you can take some of these technologies and use them for everything and try and espouse that they will solve all your problems, but they often have things that they're really good at and things they're not so good at. So what you really want to try and do is take the best technologies you can and apply them in the best situation or the best way you can to give you the best results. So tonight, obviously, I'm focusing on utilizing Docker with Openstack to try and give you all those pieces. So once again, if you think back to the application ecosystem, we have our front door, data stores, operations management. So now let's look at that application space. Obviously, you're all here tonight at DevOps Brisbane, so you're all really interested in DevOps. You're all really interested in things like getting your deployments easier. You're interested in things like getting developers more involved in operations and being able to push code to production quicker, repeatable builds, immutable infrastructure, those kind of things. And Docker is really, really good for that piece. It's an incredibly powerful packaging tool. That's really what it is at the core. Because if you ask what Docker is to many different people, they say things like container management and so forth. If you really want to understand, I guess, its purpose right here and now, is it just a really powerful packaging tool. We've seen packaging tools before. Most programming languages have their own kind of packaging tool or ecosystem. And then Linux itself, there's millions of different package managers. And Docker just tries to take that one step further and say, well, rather than just try and package, for this operating system or package for just this language, we'll take that whole stack all the way down to the operating system layer, and we'll provide that as a clear package unit that you can use. There's been an explosion of tools and an explosion of ecosystems around managing and deploying Dockers. And if you don't believe me, I'll show you an example in a minute of just how many tools have come out. By design, and someone correct me if I'm wrong, the idea is that Docker containers are meant to be immutable, which means that you should not, in theory, be storing any persistent data inside your Docker container. Docker does have the ability for you to attach external volumes into it, and in which case that's okay. You can kind of persist your data onto that, so that way when your Docker dies, your data's still safe. But the general idea at the moment is you should really not put any data inside of, or keep data inside of the Docker container itself. It's especially interesting for those people who are running things like databases inside of Docker. Why is that a problem? So a lot of the Docker management tools, and even just the way people are using Docker at the moment, one of the things people are excited about is it takes that. So let me take one step back. When we started looking at cloud infrastructure and things like Amazon came along, it was a really good revolution because the idea was we could treat our servers as cattle rather than pets. We could just throw away servers and rebuild them and so forth. Docker aims to take that one step further. Is that containers are very lightweight, they're very quick to spin up, they're very quick to destroy. So you can have 10 of them, you can have 100 of them easily, and there's no kind of live migration between physical hardware. There's no kind of hard management of them. If you need to move one from one place to another, you will just simply destroy it and recreate it because they're immutable. There's nothing kind of that you have to worry about saving inside of them. They're a very attractive workflow for repeatable deployment because of that reason, because of the fact that they control so much of that vertical stack. They give you that dependency that, yes, I know what I tested in stage is going to be the same as what I'm running in production. And because they're lightweight, and because you don't have to worry about, oh, well, do I need to push configuration management changes into this or that or the other? Because they're immutable, you can just destroy, create, roll up, roll down very quickly. They're very attractive for repeatable deployment. And they synergize well with 12-factor app design. So for those of you who don't know, I believe Heroku came out with, I guess you could call it a bit of a manifesto or an idea of what they call the 12-factor app, or what they think applications should do in the future. And it seems to be very much around the kind of container and Docker-like workflow. So if you're interested in what the Docker ecosystem looks like already, there's someone who's made a really incredible mind map on the internet. Hopefully, once again, this will work. So you can see already that that collection is quite large, barely fit on the screen. So we've got everything from container-based operating systems to platforms that can do Docker hosting already, configuration management tools that integrate with Docker, networking projects specifically related to Docker, and this quick big pile over here of Docker management tools, of which we'll look at 2 tonight. And I would have liked to done more, but once again, I'm on a time limit, and I can be here for hours, so I'm trying to go through each one of them. So I'm going to attempt to do a couple of small demonstrations. Before I jump straight into them, I'm going to quickly talk about what I'm going to be showing you. So the demonstrations tonight are probably a little bit bare-boned. They're very simplistic examples, very much low-level under the covers kind of stuff, utilizing Openstack to try and deploy a little bit of some infrastructure, and then a bunch of Core OS machines, which is a Docker-based or a Docker hosting platform. And then I'm going to be deploying a very simplistic Docker application, very, very simple, inside of that, inside of those Core OS machines. And then we're going to utilize a load balancer that's sitting inside of Openstack to actually load balance requests on top of that. Hopefully see that all in action. The second demonstration I hope to do is just using a Docker management tool called Shipyard, which I believe is one of the earlier management tools, to just kind of show you the difference between the first demo and the second demo. The first demo I'll kind of be doing things a little bit more manually. Apologies for having back to the audience, so I'll just start setting everything up. you haven't seen an Openstack UI before, this is basically a standard Openstack installation. What I will show at the moment is, right now when we're starting out, we have no virtual machines running, we have no instances, we have no volumes. If we have a look at the network infrastructure that we have, we'll see it's very basic. We've got one default network that's given to us by default, which we won't be utilizing. And then we've got a public network range, which you consider in our cases like the internet, your publicly accessible kind of network. We've got nothing under load balancers here or anything here. So what we're actually going to do is we're going to go into orchestration, and we're going to use a heap template algorithm to spin us up all these different pieces of infrastructure we're going to need. So you can see here on the launch stack screen, it's prompting me for a bunch of variables, and these things that I've already set in my heat template, I need to prompt the user to ask for. There might be passwords or certain various bits and pieces. I'll input that data, and that will then be used by various other parts of the infrastructure to populate different things. So every stack needs a name, easily enough. Like that. Choose the number of Core OS machines we're going to run, just 3 for the moment. We can choose how big or small we want those Core OS instances to be. So Core OS relies on a couple of interesting technologies underneath the covers. One of them is called etc.d, which is web-based. I guess you could say it's like a web-based API for doing configuration management. The way Core OS uses it is to actually talk to each other and discover each other. So one of the things I need to actually tell the machines here is you need to talk to a particular server, and you need to actually register yourself with a unique kind of token so they can actually discover each other in the kind of cluster. Typically, if you're doing an on-premise installation, you'll probably use an on-premise installation of etc.d. Just for simplicity's sake, I'm using one that's on the internet that the etc.d developers provide. So I can just go to /in on discover.etc.d.io, get a random token that's completely unique to me. If I can paste it. Delete that here. And then finally, I just get the SSH key I'm going to put onto the machines. And then hopefully we click launch, and it doesn't completely bomb out. We can see that it's currently in progress. Actually have a look here. You can see there's quite a few bits and pieces it's building. You notice how all these different bits and pieces are connected. So if you write your template right and you use the ability to link and map dependencies correctly, it should know what order to build things in. Obviously, you can't build a virtual machine until you've got a network or a virtual network that you want it to be connected to. So there's a certain order, and it should be intelligent enough to figure out the order of those things. Unfortunately, displaying it is a little bit wonky. It's probably not very readable. So we can go over here and actually have a bit more of a detailed view about what's going on. So you can see here I've got things like machines. I've got various different networks. I've got floating IPs, which are public IPs that are going to be bolted on top of some particular bits of infrastructure. We have load balancers down the bottom here. We've got routers, those kind of bits and pieces. So if we go for that, refresh. Hopefully this is complete. This says create progress. It says create complete. So everything is complete. So what that actually is. So let's go back and have a look now at what we have. So we have a bunch of machines running, including one running MariaDB, one running etc.d, and 3 machines running Core OS. We actually have a look at our network topology now. We'll see it's actually been populated with more things. So it might be a little bit hard to see depending on how far back you are. But basically we've got our public network now. We have an operations management network with one server in it. We have a data store network with one server in it. And we have a core OS network that has 3 core OS machines inside of it. And you can see they're all connected by a router that's at the top, which will also route outwards, which means that those instances can talk to the internet. And for instance, the core OS machines need to talk to the Docker registry. This is all configurable. You can do this however you please. That's one of the great benefits. If you want certain machines to have internet access and certain machines not, you want certain VLANs and other bits and pieces to only talk to other VLANs and so forth, you can just sit there and configure it onto your heart's content. So basically now we've given us, Openstack has given us a whole bunch of private networks, a whole bunch of infrastructure. It's even given us a load balancer on front of all of those core OS machines. You can see here a load balancer in front of core OS. You can see it's active. You can see them provided here, so that's when I was talking earlier about the plugin support. So I'm just using the HA proxy as my provider here because this is a cheap environment. I don't have the money to afford big expensive load balancers. But you know, if you do have a hardware load balancer and it has Openstack support, and a lot of them do, you know, you can utilize that in your design as well. You'll know how to configure those load balancers and talk to your virtual machines. So if you have a look at some of the members of the pool, they are called 808080, which we'll do in a second. So the last thing I'm going to do is one of these machines, I'm actually going to attach another floating IP. This is something I wouldn't typically do, but just for the sake of this demo, I'm going to do it just so I can SSH onto the box and actually show you, go into a core OS machine itself, upload some Docker stuff and kind of stuff. Typically, you'd probably want something a little bit more sophisticated than what I'm doing here. So before I go on to the machine, what I'm going to talk about next is, I guess, Core OS and one of the tools it has, and a little bit about Core OS, I guess, itself, and some of the management tools it provides. So Core OS is a very stripped down, I guess you could say, operating system that's solely designed for running Docker. It has the Linux kernel, it has systemd, and it has Docker, and that's pretty much it. Everything else they try and cull out as much as possible. So what it's really designed for is just a platform for running Docker containers. There's one tool that it also uses as well called Fleet. And Fleet, more or less, is distributed systemd. So systemd across multiple systems. So it's kind of interesting in that Core OS at the moment, especially, relies heavily on systemd and the functionalities it provides. So how we're actually going to run our containers on top of Core OS, we could go onto each of these machines and we can start them up manually ourselves, do the Docker pull, use the Docker tools. We're actually going to use Fleet to just kind of go on and tell Fleet to deploy some Docker images across the cluster, and it's going to do it for us. Fleet, as I mentioned, operates off the idea of distributed systemd. So when we actually look at what a service file is to actually start a Docker container. For those of you who might be familiar with systemd, this is actually just a standard systemd unit file, just like you would use to start any normal Linux service on any Linux distribution. So you can see here I've got a few commands that are kind of tricks to make sure that a certain start and stop works correctly. So basically, more or less what I'm saying here is systemd, when I tell you to start a service called this one, Nginx DevOps.1, I want you to actually do a Docker run name Nginx.1, expose port 8080 to port 80 of the container, and that last thing along the end is the actual Docker image we're deploying, which is called Nginx DevOps, which is just the Nginx Docker image with a couple of custom content I've thrown in. It's fairly simplistic. You'll see at the bottom there's something that's talking about xFleet. So those are just some some scheduling directives given to Fleet itself. So when I say start all these Docker containers using Fleet, I want to also say for each one of these Docker containers, they're going to conflict with each other because they're all going to listen on port 80, so don't put them on the same machine. So that's why using that syntax there, I said anything with DevOps.star.service in the name, don't put on the same machine, and it will try and respect that. So let's actually copy them up. So we're actually on one of the CoreOS machines now. So if we actually look at, we have the full Docker tool chain here, so we can do Docker PS. We can see there's no Docker containers running at the moment. So let's look at that. We have systemd on here, so we can go and we also have fleet, which is fleet CTL, and we can list the machines that are connected. Oops. We can see how 3 CoreOS machines are connected. They're aware of each other. They use that discover.exception.io token to authenticate and communicate with each other. So what we're actually going to do is we're going to fleet CTL start all of my start service, which is basically all of the service files I have in the current directory. So you can see there that it actually says it's now launched those services, and it's launched them on 3 different machines there. You can see by the IP on here. So we've submitted the jobs to Fleet, which is basically the CoreOS cluster. It's figured out, it's distributed those service files to the systemd installations on all of those machines, and then it's figured out where it wants to start those Docker containers or run those services.
Does that include this machine stuff?
Yes. So if I do, so I'll need to figure out which one of those is on this machine. So let's go 10.5, was it? So the DevOps 2. So you can see here, that's just using the standard systemd tool. You can see here that when we started it, it said, oh, I don't actually have the Docker image Gillies/Nginx DevOps, so it's pulling that down. So if we do a Docker PS, it's probably not running yet. So it'll take a little bit for it to actually download the Docker image from the Docker registry. Hopefully not too long. And then we'll actually see that running. And when that's running, then we'll actually know that probably about the same time it'll be running on the other containers. We can actually go back and do a HTTP request with the load balancer, and we should see the content that we're getting from the Docker container. Despite the fact this isn't a data center with an incredibly fast pipe, I never seem to get good speeds from the Docker registry. I'm not quite sure why. And it's not a big yeah, so well, for a while there was a project by Docker to do a private registry, but it was quite anemic. I believe it's picked up steam now, and I can guarantee you there will be more. I think there already is even more and more private Docker registry solutions out there. Because obviously, if you're a company that's got proprietary code and what have you, you can't just. There might be obligations where you can't necessarily use the public image. So yeah, sure. Once again, I could probably in my operations management layer, I'd spin up another instance that might be a Docker registry, and I could do all this bits of orchestration as well. There we go. So at least it's running now. 26 seconds ago. So what does that actually mean? So if we go back over here into Openstack now, and have a quick look at our infrastructure again. We can see now that there'll be a Docker container running on port 8080 in all three of these instances. If we go and have a look, our load balancer should be set up, it's running. It's got port 8080 in the pool. It says they're active. So now all we need to do is find the floating IP, which is the public IP that's connected to that load balancer. Should be this one here. And we can see, so that's basically going through the Openstack load balancer at the front door. It's going straight to our CoreOS machines on port 8080, which then Docker itself has port mapped back to port 80 inside the container. You can test that it actually is load balanced because I'm putting the host name of the machines there, and in theory that should change every time I hit refresh. It should go between 3 different ones probably. So yeah, probably not the most exciting demo in the world, but I'm hoping it's kind of demonstrating the concepts of that we've built all this infrastructure around it, we built Docker itself, and we've gone in probably through a kind of very basic management process. We've uploaded some Docker containers and put that into our infrastructure. And you can imagine that the systemd unit files I've got there are actually set to pull the latest tag from Docker each time. So if you wanted to do an application upgrade, like you upgraded your application container and you push that up to the Docker registry, I would just have to go on and just signal a restart of those Docker services. That would pull down the latest one and put them back up there. So it's a very quick and easy kind of deployment. So the second demo I'll probably show, which I was building another environment in Openstack from the ground up using Shipyard. I probably won't do the building from the ground up part because the amount of Docker images you have to pull for that example is a lot longer and it takes probably about 10 minutes and I don't want to run out of time. The good news is I did anticipate that and I've got a pre-prepared kind of installation, so I'll probably demonstrate that instead. So this one's slightly different. I have 3 RHEL 7 machines, so Red Hat Enterprise Linux 7 machines running Docker. I have a Shipyard server that's just running Shipyard, and I've also got my MariaDB, which would, in this example, be considered a data store. So if we look at our network layout again, similar to before, I have an operations management network which the Shipyard server sits in. We have our Docker server sitting in a Docker layer, and then we have our data store sitting in a data store layer. A simplistic example. This time I'm not using Openstack to put a load balancer in front of them. The reason is because of that is Shipyard itself is very interesting, and this is one of the things we kind of see with a lot of the cloud projects in general, in particular Docker ones. There's that gravitation towards the Docker management systems trying to provide you a full PaaS or platform as a service. So in this case, we'll actually see Shipyard itself act as a load balancer on top of the Docker containers it manages. So let's jump into that very quickly. So we find the public IP address for Shipyard. So we can see here, this is the main user interface for Shipyard. It talks about containers, images, applications, and hosts. So we have a look at hosts. We can see all 3 of our RHEL 7 machines are registered with Shipyard. They're running the Shipyard agent. So these are just basic RHEL 7 machines. These aren't CoreOS machines or anything like that. They're just standard Linux systems. Could be Ubuntu, could be RHEL, could be CentOS, could be anything. They just run a small shipyard agent, and you tell it the address of the actual shipyard instance, and they register in, and then you actually have to flag them to join the cluster. What's interesting is the shipyard agent itself, you actually run inside of the Docker container on the system. We actually look at let's start by looking at the images. So, sorry if it's a bit hard to read. That work, maybe. You can see here that the images that are listed as being available on those systems so far is only just the shipyard agent, because that's the only thing I've got running. I've got nothing else. And then each one of the running containers that should be on the system so each system is also running the shipyard agent as a Docker container, so that should be kind of obvious. So what we're going to do is we're going to do probably a repeat of the example I did before. We're going to import an upstream Docker container. I custom built one, which is very simple. We're going to import it. Hopefully this doesn't take too long, but so we'll give that a few seconds, and it's actually pulling down my Docker image on all three of those hosts now. What we're next going to do is we're going to go into containers at the top there, and I'm going to start a container on each one of those systems using that image. And then last thing I'm going to do, hopefully if I get time, is actually create what Shipyard calls an application, which is basically a load balanced instance of Docker containers. So it binds them all together. So once again, it's performing what I did before, but rather than using the low-level guts of system D and all those kind of things, it's through at least something that's a prettier interface. Shipyard is by no means the only Docker management framework or application that's out there. As you saw before, there's heaps of them in various states of features, functionality, goals, ideas. So yeah, I simply chose Shipyard just because it's one of the older ones, one of the first ones. But as always, only you know your workflow, so do your research on the tools yourself, for sure. So what's the chances this is actually finished? So what I'm going to do is I might go wrap up the last bit of the talk while we wait, and then I'll circle back around and try and demonstrate the last bit of the demo. So the future. These are just a couple of points I thought worth mentioning about where I think the future holds and what things like Docker and Openstack means for us. Everything I've talked about today, especially under the banner of next-gen infrastructure, is by no means complete. Indeed, we could probably run a whole series of sessions on next-gen infrastructure and different parts of it. Everything from just focusing down on operations management tools to focusing down on those front door tools and even data stores in general. I think operations with these kind of tools like Docker and Openstack and so forth will be in a better position and be better able to provide infrastructure and platforms as a product to developers. So what I mean by that is hopefully we'll see operations teams start to make a transition where they'll actually kind of version their infrastructure and treat that as a product, not just the product you write as developers and use for your products, but the operations team just within themselves can start to go, you know what, we're going to start doing sprints and we're going to provide this functionality or these features of our infrastructure as a service to developers and to themselves as consumers of that infrastructure. With things like Docker, developers should be able to better build their applications and provide repeatable workload deployment units. So, as you can see, what we talked about earlier, Docker tries to own as much of that vertical stack as possible and keep it consistent, keep it immutable, keep it repeatable. So, with things like Docker especially, we should be able to provide better, repeatable, workable deployments. And that's not without challenges. Obviously, with immutable infrastructure, there's things like how do you sync container state with database state and things like that. So there's a lot of challenges there. But hopefully, as we learn and use containers and other technologies more, we should be able to iron those things out better. both developers and operations can unify design and management of entire ecosystems. So you can see, hopefully, with that kind of demonstration of the power of Openstack Heat earlier, what I'm kind of talking about. It's not just a case of here's some application code, and maybe here's some configuration management modules to kind of deploy that. It's everything. We can sit down with an operations staff and a developer can sit down and actually start looking at all the pieces of the infrastructure. Do we need a load balancer? How's that going to look? What networks do we need? What separation do we need to provide? All those bits of infrastructure, hopefully you can kind of work on together, put it in something like a heat template or whatever kind of tool you want to use to kind of capture the whole picture of infrastructure, not just, oh, this is an application piece of code and it has a configuration file that needs to look like this. You want to be able to capture everything and then keep repeatedly deploying all of that infrastructure. We'll continue to explore containerization and see how far we can push it. So already, as I showed before, the ecosystem, we're trying to take containerization in a whole bunch of different directions. Certainly for the application space, getting more application code repeatable, deployable, is certainly very fascinating. People now are starting to push into, can we use containerization, or how can we use containerization at the data store layer? So they're doing things like pushing databases into containers and things like that. And that's kind of an interesting concept. Personally, I'm not completely convinced it's the way to go yet. I may very well be wrong. And the other part that people are doing, as we can see in the shipyard hopefully in a little bit, is that people are trying to push containerization on the front door services as well. They're trying to run load balancers inside of containers and so forth. That's probably not a bad idea. Networking on containers is still a very tricky thing, so that might not be as easy as it sounds. But there's a lot of exploration going on. We're trying to see how far we can push those boundaries and what works and what doesn't. Infrastructure as a service, platform as a service, containers, configuration management, orchestration solutions, they all have to become more aware of each other. And you can kind of see that in the example here. You know, Openstack and Openstack Heat, things for example, knows all its bits and pieces, but it doesn't really know about, say, Docker containers, although there are some Openstack projects related to that. Likewise, things like CoreOS and Shipyard and that, at the moment, they don't really care whether they're running on Openstack, whether they're running on Amazon, or whether they're running on bare metal. So you kind of lose a bit of nice functionality there by those kind of silos where each technology is just focusing on itself and not kind of thinking about or being able to interface with the infrastructure around it. You want these things to kind of all be aware of each other, so that way you can get that tighter integration and better workflow. Dedicated hardware devices will be around for a while, but they'll give way to software-based solution. So what I mean by that is, you know, big storage arrays, big hardware load balancers, big SSL terminators, things like that that are, you know, obviously very typically expensive for operations stuff to purchase in their budget, and are definitely needed when you want to get up to massive scale. They're not going anywhere for a while, but we are seeing software-based solutions starting to kind of edge into that. So we're seeing software-based storage in Ceph, Gluster, and Friends kind of take over the storage space here and there. Obviously, even things like HA proxy in its simplicity, people are trying to push to the limits more and more to replace hardware load balancers. And then there's also software-defined networking, which is very much in its infancy, but obviously wants to try and tackle the problem of, do we really need to pay Cisco all that money for expensive switches? We probably still will need to for a while, but hopefully we can start to replace those with software-based solutions. And the advantage of that is they usually have better APIs and can better integrate into your ecosystem. So a couple of projects to keep an eye on. Once again, my personal opinion. So Google Kubernetes, I think that's how we pronounce it. I'm probably wrong. Was recently announced. It's their Docker and container orchestration system. It's not really usable by itself yet, or its usability is about on par with the kind of Fleet example before, but it's interesting. It's very strong, it's very solid, and a lot of people are looking at integrating with it, whether they're building an API or platform on top of it, and it does the orchestration underneath, and different things like that. So it's very powerful. Red Hat OpenShift, I guess I wouldn't be earning my money if I didn't mention Red Hat at least once. I've tried not to most of the presentation. So Red Hat OpenShift, which is a platform as a service tool, recently announced their technology roadmap for version 3.0 of OpenShift. And it actually includes Google's Kubernetes, and it includes Docker, and it includes other bits and pieces around container management and to better provide you kind of a rich platform as an experience, platform as a service experience. There's another Docker-based platform as a service platform called Flint. Also seems to be gathering a bit of interest out there as well. A lot of these projects are still immature. All of these ones I've mentioned here are very much in pre-production phase. And someone may come out tomorrow with a better tool. It's always the way. But it seems to be gathering a bit of steam and momentum at the moment. And there's one more Openstack project which I haven't mentioned, which I do think is important to keep an eye on, and that's Openstack Solve. So the best way to kind of describe that project is to try and provide you a full development workflow as a service. So we think about infrastructure as a service and so forth. It's trying to actually provide you development workflow as a service. It's a very ambitious project, but it's obviously doing, it's got quite a lot of interest because it aims to utilize things like OpenStack, so you can actually, once again, template and design your whole development process. This is where my code lives. This is where my Jenkins instance lives. And if they don't exist, it will make them for you. It will run test infrastructure. It will spin up test instances for you and create networks and everything. And then, handle how do you gate and push to production and those kind of things. Once again, a very ambitious idea, but, it's very interesting. So that's questions, but before I load that, I'll have one last crack at jumping into the shipyard example, and hopefully kind of get that up and running. So we see that's actually pulled down the container now. So I'm going to create a new container from that image. So basically these options I'm putting in here are the options I would have provided to Docker on the command line, more or less. And I'm going to say I'm going to run it on all hosts. So we can see one of those containers now is running on each one of these hosts. Just running my standard Nginx DevOps container. The last thing we're going to do is we're going to bind them into an application, which is basically utilizing the load balancer functionality of shipyard itself. So very quickly. That's all right. Just throw them all in there. It's because it's detecting that shipyard agent isn't actually listening for their hands. So I mean, actually. actually leave it there. Anyway, what I was going to demonstrate was that I would actually go into Shipyard there, I would actually create an application, puts a bunch of settings in, bind it to the 3 Docker containers that I had running for my Docker container. It would actually create a load balancer on the Shipyard server itself, which is kind of an interesting idea. And then I would actually be able to go to the Shipyard, a certain port on the Shipyard server, and it would actually route that request through the Docker containers and do it before. So I guess more or less what I'll cover now is anyone has any questions? Sure.
Have you got experience in elastic capacity for deploying particular VMs and putting containers?
Yeah.
You mentioned at the beginning that you have connection up.
Yeah. I haven't done it.
Openstack.
Sorry.
In Openstack.
Yeah, so I haven't done anything beyond academically at OpenStack. I've definitely done it on Amazon and AWS.
Yeah.
But with OpenStack, I've definitely tested it in terms of academically. Most of the services we've been running on OpenStack so far hasn't actually involved Elastic workloads like that. So the Elastic workloads we've been running mostly so far have been around basically things like heavy computational work and things like that, so it's slightly different. It does in theory work, and as I said, I have tested it in academic examples and it has seemed to work. But as if anything, especially like OpenStack, I will not lie, it would not surprise me if there's bugs there that need to be ferreted out.
So I'm interested in the concept of changing like